the solution of the fourth quiz. First question, find the area of the region between the curves y equal to square root of x and y equal to negative 3 square root of x and x equal to 0, and the last one x equal to 4. Here is the sketch. This is the square root, y equal to square root, and the bottom one, this is negative 3 multiplied by square root. So the area that we're supposed to count is the shaded area, the light blue area. So let's go through finding it. We have to take the integration between 0 and 4 of the square root of x. We just put it as x to the power 0.05 minus, and then we have minus 3x to the power 0.5, which is square root of x dx. We can see that the negative will change to positive because negative and then negative. So it will change to positive and we'll be adding x to the power half to 3x to the power half. That will give us 4x to the power half. And then we just do the integration normally. So integration between 0 and 4 of 4x to the power half dx is going to be equal to 4x to the power 1.5 divided by 1.5, and we have to evaluate it between 4 and 0. And that's going to be equal to, we have to take 1.5 outside. 1.5 is equal to 3 divided by 2, but when we take it outside, we're taking it in the numerator, so we will flip it. So this is 2 divided by 3, and then 4x to the power 1.5, and we have to evaluate them between 4 and 0. This is going to be equal to 8. Why? Because we have to take the 4 outside. So 4 times 2 is going to be 8 divided by 3. And then inside we will be left with the square root of x to the power 3. And if we do the math, that's going to be equal to, when we plug the 4, first we'll get the square root of 4, which is 2, and then we raise it to the power 3, which becomes 8. So we have 8, and when we evaluate with 0, we get 0. So 8 multiplied by 8 is going to give us 64 divided by 3, and that's the correct answer. That's the end of this question. Let's go to the next question. We have to find the area of the region between the curves. And the curves are as follows: y equal to 2x squared minus 4x plus 4. Y equal to negative 2x squared plus 1. X equal to 0. And x equal to 2. To find the region, we have to do the integration between 0 and 2 of the first function minus the second function. And this is pretty much the integration. The first term, this is its integration, and this is the second term's integration, and this is the third term's integration. And the same thing for the second function, which is subtracting. We're subtracting this function, so we need to get the integration of this function, and this is the integration of that function. We have to evaluate between 0 and 2. Here is the evaluation of the first part, which is the first term over here. The first term will give us 16 over 3. The second term will give us negative 8. The third term will give us positive 8. Minus, this is the second term. The second term, the first term of the second will give us negative 16 over 3, and the plus 2. And of course the 0 we're not going to count. So if we do the math, this is going to be equal to 26 divided by 3, which is the answer for this question. Next question. Find the area of the region between the curves. We have y equal to 2 square root of x, and y equal to x squared divided by 4. We're not given the limits of integration. Since we are not given the limits of integration, we have to determine the values of x for which the values of the two functions are equal. To do this, we can do it by letting 2 square root of x equal to x squared divided by 4. This implies that 4x minus x to the power 4 divided by 16 equal to 0. And this implies 64x minus x to the power 4 equal to 0. So, and this implies we take x as a factor, we will have 64 minus x cubed equal to 0. Now from the last part, both functions have the same values for x equal to 0 and x equal to 4. So these are the two solutions of this equation. We can have x equal to 0 to get a 0 of the left hand side, or we can have x equal to 4, and that will give us the 0 of the second term, which is between the parentheses. Now we have the limits. We can just go ahead and do the integration, and this is the first function and this is the second function. So if we do the math, integration of 2x to the power half will give us 2x to the power 1.5 divided by 1.5, and integration of x squared divided by 4 will give us x to the power 3 divided by 12, and this is subtract, and we have to evaluate it between 0 and 4. And if we do the math, we could just go ahead and plug in the values. So the first will give us 4 divided by 3 multiplied by 8 minus 64 divided by 12, and that will yield 16 divided by 3, and that is the correct answer. Let's go to the next question. Last question. Find the area of the region between the curves y equal to 2x squared plus 1, y equal to x squared divided by 2 plus 2x minus 4, x equal to 0, and x equal to 1. Here is a sketch. The top parabola represents the first equation, and the bottom one represents the second equation. And the area we're interested in is the shaded area between the two, and of course from 0 to 1. That's the value of x when x equal to 0 and when x equal to 1. So to find the area of this shaded, to find the area of this shaded region, what we can do is just integration of the difference between the first function and the second function. This is the first function, this is the second function. This is integration of the first function, integration of the second function. We have to evaluate it between the limits which are 0 and 1. And if we do the math, that's what we're going to get. Basically, we can just take the 1 and plug it for every occurrence of x here. We will get 2 over 3 over here, and we'll get plus 1. That's the first function. The second function, we will just plug in the value 1, and over here that's going to give us 1 over 6, which is the first one, and then 1 square is 1, and then minus 4 times 1 is minus 4. And if we do the math, we're going to add them up. This will give us 5 over 3, and this one will give us plus 17 over 6, and that's going to be equal to 4.5, and that's the answer. And that's it, and thank you for watching. I hope you enjoyed the video.